Welcome to Sensible Health Solutions, the show where we simplify health and wellness. Join your hosts, Hallie Fields and Dr. Scott Luper, as they share practical tips and expert insight to help you navigate common ailments, nutrition, and overall well-being. Tune in for straightforward advice that empowers you to live a healthier life.
Good afternoon and welcome to Health Talk. My name is Hallie Fields and I'm your host today as we talk about health, how to get it, and how to keep it. With me, as always, is Dr. Scott Luper. Dr. Luper is a naturopathic doctor, and today we're talking about how to get healthy. Hello, Dr. Luper. How are you?
Hello, Hallie. I'm doing fine.
Good. Staying healthy, staying happy, staying warm.
Yes. Though I'm overworked. But what else is new?
That's life.
Well, we just keep going at it. And I'm determined to do everything possible to help my patients and honestly help the people be healthy.
And
that's
the
why
community.
That's why we're doing
wellness.
the show. That's right. We're education. Education is power. And so I decided today to do a show on the immune system because it's such an important part of our quality of life. If we got a good immune system, then we fight off infections and to the point where we don't even know we ever had them. And if we have a bad immune system, then we have these horrible infections that severely impact the quality of our life to the point that, heaven forbid, they kill us just outright.
Right.
So I think it's useful to talk about immune systems and then also to have, along with talking about these different parts of immune systems, talk about ways we can keep our immune system healthy. Now, I want to just confess that, like with every single show like this we've ever done in the 14 years we've been doing this, the answer is
Eat right and exercise.
that's right.
Drink water, sleep.
Yeah, it's the same as it always is. But what can you say? That's what works. That's what keeps our immune system healthy. Now, there's some other stuff as well, so we want to go through the whole thing. But it really, in order to get the system to work well,
You got to have the 4 basics down.
you have to be working well.
Yeah.
Yeah. What are the 4 basics?
Eat right, exercise, sleep, hydrate.
Well, hydrate's important. You're right. Hydrate's important. I put in bump hydration, and then taking vitamin D is important too. But
Yeah.
I say purpose. Purpose. You got to have purpose. Purpose
Okay,
is
so
one
top
of those.
5?
Well, you could call it 5. Then we'll leave hydrate in there. All right. Anyways, let's talk about your immune system. Now, let me give you the quick overview on the immune system. Because you think your immune system is your white blood cells, right? And that's your immune system.
Yeah.
It's not.
Oh.
It's not. The white blood cells are a part of it, but it's not the way to think about an immune system. Immune system is any part of you that helps you resist infection.
So your skin?
Yes.
Wow.
Your skin turns out to be a super important part of your immune system, probably the most important part.
Get out of here.
No, really. Because you think about it. What are we? We're meat.
Yeah, meat sacks.
We are meat. Yes, we are bags of meat. Yeah. And what keeps the meat from rotting? It's the bag. You got to have this covering. Now, if you're covering your epithelium, now it's both inside and out. We're not just talking your skin only, because you have an epithelium that's covering the inside of your nose and your ears and your mouth and your digestive system and lots of you. That part is as important, if not more important, than the stuff on the outside. Let me just say it this way. The wet skin is more likely to get an infection than the dry skin. You got a lot of wet skin in you.
Yeah, that's for sure.
Really?
Yeah.
And so that is super important for how your immune system works. And really, if you want to talk about the white blood cell part of your immune system, 80% of it is lining the wet skin part.
Wow.
Because that's where the action is, not the dry skin part. Okay, so let's break your immune system down into 2 basic kinds.
Sure.
The first one is the stuff that works no matter what bug it is. And that's called your innate immune system. The innate immune system just works on stuff because it looks like it's a pathogen. Let me give you an example. Bacteria are really common pathogens, and they'll take advantage of you if they can because they're trying to make a living. Now, the bacteria, there's two main kinds. There's gram-positive and gram-negative, and they both have this cell wall that goes around their membrane that toughens it up. It makes them able to withstand the vicissitudes of life on planet Earth, right? So they're tougher than average, and they are. Bacteria is really tough. And part of the reason why they're tough is because they got this coating on the outside of their cells. And the coatings are different depending on whether they're gram-positive or gram-negative. Now, our main innate immune system is the bacteria can't get in. Because we have this sick skin and they just don't have the means to get in. In your wet skin part of your immune system, it's covered with cells, same thing. Those cells are kept in the best repair they can be. And as long as they're in good shape, the bacteria can't get in. They cannot muscle their way into us. Now, with rare exception, there are a few kinds of bacteria that figured out a way to penetrate the epithelium. They got this little gizmo on them that bores into us like the Underminer, you know, that movie from the cartoon movie, it's called The Incredibles.
Yep.
And it's in the end, they have that guy who's he's going to take over the world, and he's got this submarine with this little drill on it. Yeah, like that. Except for it's all microscopic, right?
Sure.
Sorry, my obscure references. I'm sorry. I'm a nerd.
You have
occasionally.
a child.
I do that with kids in my life. Yeah, so I have the things I think, right? All about cartoons. Anyway, so when you get these occasional bacteria, but those are the exceptions. The vast majority of them, billions of different, bacteria and kinds, they just can't get in. So if your epithelium is in good shape, then the chance of your immune system needing to kick in, really, it just goes away because there's nothing to kick in against, okay? So that's a main part of your innate immune system. Now, this wouldn't be an interesting show if we just left it there, right? Because bugs do get in. There are breaks. You get sick, or you eat something funny. You get a French fry that's off, or whatever, right? And you get some kind of little damage going in your digestive system. Some of the cells get sick and die. They fall off. You got a little hole. Now bacteria can get in, and boy, do they ever. They're diving in, trying to get access to the juicy bits right inside us, and so they come into our tissues and heaven forbid in our bloodstream. Now what? Well, we got this backup thing that's part of the innate system that can recognize the cell wall on bacteria, both the gram-positive kind and the gram-negative kind. And what it does is it's got this little protein that's floating around in our blood all the time, and that protein gloms on to the cell wall of the bacteria, and it attracts other proteins, and they line up. Click, click, click. They all fall into place, and they punch a hole in the side of the bacteria. True story. All automatically. We don't lift a finger. This is absolutely part of the innate immune system. It just kills bacteria like nothing.
It's incredible.
Bam. Puts these holes in it. This is called the complement system.
Oh.
Okay? And there's a different pathways in the complement system, and it works a little differently depending on which pathway you use, but they all boil down to the same thing, which is they drill holes, lined holes, mind you, like a little tunnel, a little tube tunnel, like the kind of thing that you would go walk down to get into the sewer, except for minus the little the sewer cover thing. It has no cover. It's just an empty hole.
Right.
And so anyways, guts can come out of the bacteria, just flow out of these holes, or stuff can flow into these holes, and it screws with the bacteria. The bacteria need their membrane to keep, the stuff on the inside separate from the stuff on the outside, and that goes away because now the inside and the outside get all mixed up and the bacteria dies. Again, there's no antibodies. There's no white blood cells. They're not doing anything. This is all just innate. This is like having skin, except for this time the skin jumps onto the bacteria and punches holes in them. What a fabulous system. Now, the interesting thing about this is lots of creatures on the planet Earth, this is their immune system. This is all they have. They don't have anything else. They don't have white blood cells. Like plants. Plants don't have white blood cells.
Right.
The only system they have is innate.
Oh.
They can't make antibodies. They live and die basically on their innate immune system. Insects are the same way. All they have is the innate stuff. They don't have the ability to make antibodies and any of that stuff like either. They just have their system, their complement system, their epithelial system, their chemicals that combine with other chemical system. It's all automatic. So mammals are superior.
Right.
I don't often say that. I don't want to sound like I'm bragging or anything, but in this case, I'm bragging.
Pretty popular topic. I think a lot of people could agree to that.
Mammals, they got it going because they got this extra immune system called the acquired immune system. And so what happens with the acquired immune system is we can make antibodies to stuff that tries to attack us. And what the antibodies do is they make it so where the white blood cells can go in and mess them up. We got a billion little Guidos in our bloodstream.
We have the mafia.
And they'd go in and say, okay, boss, right? Can I shoot him now, boss? Like that. Seriously, we got muscle. Yeah. Absolutely. Now, we're thinking about these bacteria, right? And they're trying to horn in on our action. And so we got these guys that have learned to recognize. Now, there's nobody with a brain here. This is all automatic systems. So they all have to kind of run automatically because we're just talking about cells, right? There's no consciousness. They just kind of run by themselves. So what they do is they can sense the flavor of this weird thing.
Yeah.
And then they
go for that.
They eat it.
Okay.
They actually engulf it because we have white blood cells that just literally eat stuff, right?
Nice.
And so they eat it. They break it down. Do I need to talk about this, how they break it down part?
I mean, if you want, expound.
Yeah, so here's what they do. They got these, because it's kind of cool. We have a microscope at the clinic, and I look at people's blood under the microscope from time to time, and I can see the white blood cells. And so I literally can see with my own eyes what this is. What we have is white blood cells, and when you look at them with your eyes, they look like they're little bags full of gems. There's these little teeny balls that are shiny,
right,
and glowy, and they're filled with these tiny little packets of poison, and the poison hits the light and lenses it and refracts it, and they glow like gems inside these white blood cells. Now, the white blood cells don't die because the packets all contained, the poison's all contained in these little packets. They're called vesicles, little balls, if you will. And what happens is when the white blood cell wants to eat something and dissolve it, it engulfs, that is, it goes around the bacteria, pulls it in, wraps a piece of membrane around it. It's completely covered by membrane. And then the vesicles come over and they meld in with the membrane and they go pop, 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 pop. You get a zillion of them, right? All popping. And then in that little membrane-lined, safe little bubble, the bacteria gets dissolved. It has a painful, horrible death. Being dissolved by acid and proteases that break it down is literally digested inside this thing. And so then the little digested hunks and chunks, the white blood cell grabs one of them, a likely one, pulls it in, and then attaches this little gizmo to it for presentation, and then pushes it out on the surface of the white blood cell for other white blood cells to come over and taste.
Oh, yeah.
Seriously. This is literally what happens. This immune complex thing is generated, and then the white blood cells come and they bounce on it. Bing, bing, bing. The other little white blood cells. Now, you want to go to some place where the white blood cells are packed thick.
Right.
Because we don't want his bloodstream with a random white blood cell. Because there's 1 in a billion of them are going to have this, to be able to deal with this particular molecule. So you want to go where they're packed in. There's a billion of them in one place. Do you know where that is?
Small intestine?
Small intestine, Pire patches is one of those places. But lymph nodes.
Lymph nodes,
Now,
yes.
Pire patches are lymph nodes for the digestive system.
Okay.
But there are lymph nodes all around our body. And they have different names depending on where they're at. But they're all basically lymph nodes. What they are is they're white blood cells packed tight. And they're just sitting there waiting for some other white blood cell to come up with this little protein and show it to everybody and say, look, look, look. This is what I
Have
ate.
a taste. Have a taste. You want some?
I ate this thing right here, and I'm leaving a lot of steps out of here because those white blood cells that eat it have to get activated. There has to be enough action going on. Remember I told you about the complement? The complement thing where it punches holes in the bacteria. That complement leaves a certain flavor in the air and stimulates the white blood cells to release certain chemicals.
Sure.
There's called cytokines. That's famous for COVID, right? People are going in a cytokine storm. The cytokines came out too hot and heavy. The whole immune system just overreacted. That's what ends up killing people in COVID. But normally it doesn't overreact. It reacts in a mild way. And so the white blood cells get activated by these cytokines, and then they go and they take their little piece that they ate and they present it. Here, look at this. And then eventually there's a white blood cell that can recognize this one. They have a receptor that fits. It's almost like a lock and key. You have this bumpy, humpy thing that matches with another bumpy, humpy thing, and they go click. The two pieces fit together. Bingo, we got a match here. This cell that just happens to randomly have this match gets upregulated. These are B cells. Now, I want to give you some of the names of the players here. I don't want to go too much into this thing, but I think it's interesting what their names are.
Yeah.
Let's go back, and I'm going to talk about the innate immune system. There's 5 kinds of white blood cells. The most important one for the innate immune system, that is, we just go in and we just eat stuff randomly, are the neutrophils. The neutrophils don't last long. They only live about 3 days. They simply get made and burn out, made and burn out, made and burn out. They're our soldiers. They're the troops that go in.
The dispensable heroes.
Yeah, dispensable heroes, exactly, right? Cannon fodder, that's what they are. And so when there's a break in the wall, that is, when the epithelium is broken, let's talk about skin. What would break the skin? You end up falling and, cutting your knee. Now you got a break in your knee. Now bacteria is coming in, so the white blood cells, in this case the neutrophils, come into this area. They're attracted by the complement and the stuff that's going on in the area, because chemicals are being released, and so they beeline in. They squeeze their way between the cells and then pop right in and then start eating stuff up. But these packets of poison are not only poison for the bacteria, they're also poison for themselves. So it's a suicide mission, no doubt. It's a suicide mission, but we have billions of these guys ready to go, and they're only going to live 3 days anyway, so they might as well go out and flash glory. So they go and they whack and stuff, and they die, and their little bodies pile up. And when they get piled up enough, there's a name for that. It's called pus. Seriously, pus, that yellow, sticky, kind of whitish, gooey stuff,
right.
That's dead neutrophils.
Oh, my God.
That's what it is. Dead neutrophils, billions of them piled up, makes pus.
I love pus. I love it. It's disgusting. I love it.
It's showing
now
your
I
immune
know
system.
what it is.
Now you showed your immune system is working. Okay, now there's another cell that's also really good at eating things. It's called a macrophage. Now, if you know any Greek, or is it Latin for this one?
Latin?
I think it's Greek. Anyways, macrophage might be a mix of the both. Macro is big, phage is eater. So these are big eaters. And this is the official name of these cells, big eaters.
Big eater cells.
Big eater cells. And what they do, they're the ones that ate the bacteria and then did the little presentation. Now the neutrophils, their job is just to eat bacteria and just whack them all. But we need a few specialists to go in, sample the badness, bring it back to the lymph node and say, ha, we got to do something over here.
This is what it is.
We got to get the next level of shock troops coming in. Remember, the neutrophils are part of the innate immune system. That is, doesn't matter who the enemy is, they're just going to whack it. There's nothing special. They're just killing anything they can get their hands on.
Is there a sequence in which your immune system kind of activates? Is it first the innate and then the... Okay.
That's actually an excellent question. So the innate immune system works immediately.
Yep.
And really it's the only immune system we have for the first 4 hours. And then after that, the other white blood cells start coming in, like the neutrophils, and start killing stuff. And some of the cells grab their little bits and carry it back to the lymph nodes. And eventually the lymph nodes will kick on and start making antibodies and attracting more white blood cells. And the big guns come in at that point. But at that point, we're 3 days into it.
Okay.
So the innate immune system is slow. It's the slowest part of our immune system. It takes the longest to get it to kick in. The innate immune system is Johnny on the spot working right now, this minute. Then there's other levels, like the other white blood cells coming in that back it up. Takes a while, a few hours for them to kick in. And then eventually, once the whole elaborate system of generating antibodies kick in, then you get the attraction of other kinds of white blood cells. So let me talk about some of the other players here. So neutrophils eat bacteria. The macrophages in the blood, they're called monocytes, and then they go to the tissues. They change their name to macrophages. They're the same thing. They're the big eaters. Then there are specialty cells, the lymphocytes. We'll talk about those guys next. Though they are super-duper good. They're the most important part of the acquired immune system because that's where the antibodies are made. Some of those lymphocytes become B lymphocytes, and the B lymphocytes make antibodies. That's their job. Some of those lymphocytes become T lymphocytes. The T lymphocytes are there to do other stuff. Either help the whole immune system work better. Those are called helper cells. Yeah, go figure. Or they're just a kill. They're the super killers. They're the A team, the elites. They're the Navy SEALs or the Rangers. Yes, absolutely. Without a doubt, they're the super killers, and they are called, interestingly enough, natural killer cells.
Metal. That is the greatest.
What a clever name.
I know.
And they are super killers, and they're really good. They go in when we need the best, except for they're not the best. They're the best for your run-of-the-mill bacteria that gets through everything kind of thing. But if you really want to get the worst enemy, it's worms and amoebas and other living creatures that are complex, right?
Parasites.
Yeah, parasites. Those guys. Those are the ones that are like, whatever, you got these cells, they're huge, right? They're trying to kill an elephant with a pop gun. The noise that's going on around them with the complement and the neutrophils, like whatever, it's a bunch of noise, doesn't mean anything. They go on and have their happy life. So we need to bring in something that's much stronger. And then what comes in at this one is the eosinophils. The eosinophils are the A team of the A team. And they're the cream of the crop, and they're the most killer of all the white blood cells. And they'll come in and put the hurt on these giants of parasites, worms and other bugs, and just some stuff that gets in our system that wants to eat us, right? It's our eosinophils that are the ones that fight that war. Now, in our modern life, we have pretty much eradicated worms and bugs and those kind of things. Now, other countries, they got bunches of them.
Yeah.
They're all over the place, but not here in the United States.
Thankfully.
Yeah, we live clean lives here. So now we got all this A-team sitting around doing nothing.
Twiddling their thumbs.
Wishing they could itching for a fight, and there is no fight. And so what they end up doing is they end up picking fights with little things that don't mean anything, like pollen and stray proteins and stuff like that. And so it turns out that eosinophils right now are more of a problem than they're an asset. And what they end up doing is they end up driving allergies. So people who have lots of eosinophils, those are the ones that break out in this horrible rash over their whole body, or they have asthma, or they get this. They
or
eat
eczema?
They get this exactly. Yeah, that's the eosinophils right now really are more of a problem than they are an asset here in our clean society.
Yeah.
Okay. So I'm sorry about that. Yeah. Now, there's a whole lot more stuff that can be talked about. Let me talk about one of the things that's key is that, well, how come these immune systems, the elite team, they rarely attack us? Now, the elite team's attacking pollen, and then we just happen to be nearby, and so our cells are affected by the white blood cells releasing their poison. But generally, the white blood cells leave us alone. They don't kill the other cells. And the way they do that is when the cells are maturing, they get a chance to interact with our tissues. They float around our body and they touch things. If they are going around our body and they touch us, then they're eliminated. There's a program that kicks on where if the out of the random choices of antibody production, they make an antibody that just happens to fit our pancreas or your earlobe or I don't know, your thyroid or your heart valve, whatever, just anything in your body, then those guys have a self-destruct program, boop, and they give it up. They die. They do that apoptosis we talked about in the last show. Remember I told you we need apoptosis to work?
Right.
Some cells need to die. These cells need to die. The ones that could possibly interact with our body, those are the ones that are dedicated to die, which makes it a little tricky because if some other bug has the same exact proteins that we do, it's hard for us to make an antibody against them. So that turns out to be one of the main ways that some organisms manage to elude our immune system is they'll cover themselves with us.
Wow.
They'll take our proteins and put them on the surface and make us. They do this little camouflage thing, and then we can't get eaten. I mean, they can't get eaten because they're hiding.
Yeah.
These are intracellular organisms that only live inside our cells. They go inside our cells. Malaria, by the way, is one of those.
Yeah.
So is TB, tuberculosis. Tuberculosis, the way tuberculosis survives, it's interesting. What the TB does, it's a bacteria, right? And so it gets eaten by the macrophages, right? And so the macrophages, or whatever cell, and so the macrophages want to take those little poison packets and then dissolve the mycoplasma. Except for the mycoplasma sends a signal out that says, we're cool. No reason to digest us. We're all happy here. Ain't no problem here. And so the white blood cell chills and doesn't dissolve them.
It was cool.
And so the mycoplasma is in this fabulous little pocket where it can't get access to a lot of food, but enough. Some of it soaks in, and so it slowly grows over months and years, living inside our white blood cells. That's where the tuberculosis lives, is literally inside our white blood cells. Now, we figured out a way around this. There's a certain kind of T cell that can recognize this, that there's something funny. That white blood cell has a funny smell to it. Yeah, right. So it'll go in and it'll give it a signal and make sure it kills all the little vacuole stuff that it's eaten. And so we actually have a way of fighting this. But the mycoplasma is so calm and cool and collected that the other white blood cells have a hard time sensing that mycoplasma is inside them, and so it tends not to kill them. So sometimes it will, sometimes it won't. So that, anyways, I don't want to get too technical into this. What kind of things can you do to help it? And there's cytokines and chemokines and toll receptors and a bunch of other kinds of stuff that it all can kick in with all this stuff. It turns out there's a lot of pieces to this story. But the big story is we got two kinds of immune system. One, which just runs by itself, doesn't need anything special, just running all the time. The other one depends on us making antibodies, and what the antibodies do is they attach to whatever the organism is, puts up a flag and says, kill this. That's really is. It helps us to identify what kind of things to kill. And so the antibodies say, right here, right now, this is the thing we need to eat. And the white blood cells get hungry for the ones that have antibodies on them and snarf them up. Or the antibodies, even another trickier thing is the antibodies start gluing together to each other. And now the organisms are trapped in this antibody glob, and they can't go anywhere, and they can't do anything because they're just gummed up. And then the white blood cells come in leisurely and then just eat all the antibody-encrusted bugs up. And there we go. We cleaned out the infection again. This system runs every day, usually where we are totally unaware of it. We probably get thousands of potential infections every day, and our body just takes care of them and just cleans them up. We don't know how many because there's no way to know exactly because it's just happening all the time. You just got to think about the half acre of epithelial tissue you have and how many trillion bacteria are there. There's occasional one or two that get through, right, from time to time, and our immune system just snarps them right up like nothing. The innate immune system is doing the vast majority of work, but when that one breaks down, we got a backup. So it's amazing that we ever get sick at all, honestly. And if we do get sick, a lot of times with the sickness, the symptoms we're getting are the symptoms of our immune system kicking in. You know, when we get that sniffle, the reason why we get a sniffle is because our immune system says we need to make more mucus
and we need to drain this
wash it out. We're gonna cover those bugs with mucus, and they're gonna drown in mucus, and they're gonna get blown out into the sink.
This has been such a fun episode. Just thinking of all my cells as like James Bond spies or Navy SEAL members.
Oh, good.
Well,
I think good, quick fun.
We are over time. Dr.
Oh, we
Luper.
never talked about how to fix any of this stuff. There's a whole bunch of things you could do. Well.
We'll have to do another one in the future sometime. Oh, thanks for being here with us today, Dr. Luper.
My pleasure.
Thanks again for being and tuning in with us. Hopefully you'll be with us next week. Stay safe, stay healthy, and stay in touch.
Thanks for tuning in to another episode of Sensible Health Solutions. We hope you found today's discussion enlightening and packed with practical tips to enhance your wellness journey. Remember, small changes can lead to big results. If you enjoyed the episode, don't forget to subscribe and leave us a review on your favorite podcast platform. Your feedback helps us bring you the best content possible. Stay connected with us on social media for more health insights and updates. You can find us at Sensible Health Solutions across all social platforms. Until next time, stay sensible and stay healthy. This content is for informational purposes only and is not a substitute for professional medical advice, diagnosis, or treatment. Seek medical advice from a healthcare professional for any medical conditions.